Hey, Science 9. Here is your practice test to get ready for your test. Please try to do this by yourself first, and you can download this file on Microsoft Teams. And if you don't understand something, then you should be watching this video to get your answers. But try doing it first rather than just watching this. And yeah, anyways, let's jump into it. So here's your practice test. The first thing we have to do is fill out this table, and it says we have the symbol sodium, Na, and we have to find the protons, neutrons, electrons, and all that kind of stuff. So the one thing that you should have is you should have a periodic table right here. So here is where sodium is right here. Okay, so here is sodium right there. So we see that Na has an atomic number. Here's the atomic number is right there. So Na has the atomic number of 11. That means when it says 11 like that, that means that is the actual proton number. So protons is 11. Now, this does not have any kind of charge up in here. So that means if the protons are 11, that means the electrons are also 11. Okay. Now, the neutrons are going to be the difference between this number right here and this number right here. This number 23 right here, 23 is the protons plus the neutrons. So if we subtract the protons, we will just have the neutrons. We know that it has 11 neutrons. So if we subtract these two, then we'll just get the neutrons. So it has 12 neutrons. So let's go back to our practice test. So this has 12 neutrons. Now we should also remember for valence electrons. Valence electrons means outermost electrons. So the outside shell of electrons. Now, the first shell can have a maximum of 2, the second shell can have a maximum of 8, and the third shell can have a maximum of 8 as well. So for sodium, which has 11 electrons, the first shell, so if I write sodium, the first shell is going to have 2, the second shell will have 8, and so 2 and 8, that's a total of 10. We're still not there yet. So the third shell will just have 1 electron because 2, 8, and then 1 will equal this number 11. So how many is in that outside shell? Well, it's just 1. 1 electron is in that outside shell. Now, we have the next one right here that says Na plus. Now, Na plus means that it is missing an electron because electrons are negative. So we have taken away 1 electron, leaving it positive. So in other words, the proton number will never change. So for if sodium always has 11 protons, okay, always has 11. This number right here is not going to change. It's 23 minus 11, which is 12. So that number is not going to change right here. Now, this electron number does change. Since this is plus, that means it had one negative taken away from it. So in other words, if we look at 11 protons, 11 positives, and we have 10 electrons or 10 negatives, that's going to give an overall charge of +1. And that's why we see that overall charge of +1 right there. Now, since it had that 1 electron taken away, what has happened is that this 1 electron was taken away. So now it has valence electrons. You can say 0 valence electrons, okay? Or since that whole thing is taken away, if you wrote down the number 8 as well, I would say that's that's also kind of right. It doesn't have that outside shell. Or you could say like full shell or whatever. Okay. So for the next one right here, for fluorine, we're going to go back to our table. And fluorine is right up here. And it has 9 protons. So it has 9 protons. Okay. Since it is an atom, that means it has no charge. It also has 9 electrons. Now, it has 19 for its atomic mass. And so 19 is the protons plus the neutrons. So if 9 of those are protons, then that means 10 are neutrons. The valence electrons, since it's 2, 8, 8, and we have a total of 9 right here, that means the first shell is going to have 2. The second shell, it has to equal 9. Okay, so here's the first shell. The second shell would have to be 7. Okay, or in other words, if I was drawing it, it would look like this. 2, and then 1, 2, 3, 4, 5, 6, 7. Because if I add these all up, it equals 9 right there. And that outside shell has 1, 2, 3, 4, 5, 6, 7. So 7's valence electrons. Now, for the next one, same thing. Fluorine will always have the same number of protons. Okay, it'll have the same number of neutrons. It'll have 10. For the electrons right here, this negative means it has one more negative electron that has been added to it. So in other words, it has 9 positives and it has 10 negatives. And if you look at 9 positives and 10 negatives, that gives it an overall charge of 1 minus, or in other words, it has 10 electrons. Okay, so we have to add 1 electron to this, and so we'd add 1 electron right there, and you'd have a full shell right there. Okay, so that outside would have 8 right there. We're going to do the next one right here, magnesium. Magnesium is way over here, and it says 12 and 24.3. So that means protons is 12. Okay. Now, for neutrons, it says 24.3. So if we go 24.3, now what we're going to do is we're going to round that to just 24. So we're going to round that to a whole number. So we're just going to round that to 24. So we're going to minus 12 from there. So that's going to be 12 neutrons. Okay. The electrons right here, it says that it's a 2 plus. That means 2 electrons have been taken away. So if it has 12, that means 10 right here. Okay. Now, if we were to draw magnesium, I'm just going to erase this one right now. Magnesium has, normally magnesium would have 12. So it would be 1, 2, 3, 4, 5, 6, 7, 8. So this would be magnesium normally, but it's had these 2 electrons taken away right here. So it's had this one taken away and this one taken away. So that's going to leave it like this. So you can say 0 or you can say 8 again, kind of same thing. Okay. Okay, last one, nitrogen. Nitrogen is way over here. Nitrogen has 7 protons, has an atomic mass of 14. So it has 7 protons, has an atomic mass of 14. So that means 7 plus 7 equals 14. So that's why it has 7 neutrons. It has no charge right there, so we know it has 7 electrons. And for valence electrons, well, let's just draw it out. 2 in the first shell. Has a maximum of 8 in the second shell, but we have to get up to the number 7. So it's going to be 1, 2, 3, 4, 5, 6, 7. So in the outermost shell, it only has 1, 2, 3, 4, 5 electrons in the outermost shell. And so we've now filled in that table. So that's how you kind of do those kinds of questions right there. Now, for naming, we're going to be naming these ones right here. So just a quick little recap. I'm not going to name all of them because I think that make the video very, very long. But right here, there is nothing in front. So if we go out to silicone, silicone is right here. So its symbol is Si. So silicone is Si. Since there's nothing in front, there's no di or hexa or penta or anything, that means there's just one. Okay, we don't write the number 1 on the formula. For fluoride, fluoride again is right here. Its symbol is F. It says tetra right there. So if we go back to our formula or our periodic table thing, and we have to go all the way down, and we see the word tetra. Tetra means 4. Okay, so right here, tetra means 4. So we're going to go back, and tetra means 4, so it'd be SiF 4 fluoride. So I have to write 4 right here. Okay. Next one, again, it says phosphorus. The symbol for phosphorus is P. There's only one phosphorus because it says nothing right there. So we just have, this is P, just 1. Oxygen. Tri means 3. So we have to write 3 oxygens like that. Nitrogen, the symbol for nitrogen is N. The symbol for chloride is Cl. It says that we have 5 chlorides, penta. Penta means 5. So we have to find 5 chlorides right there. Again, 1 sulfur. So it's just S1. We don't write the ones. Hexa, fluoride. F is fluoride. And again, hexa means 6. So we have to write 6 right there. Nitrogen, there's nothing in front, so we just write 1, or we don't write the 1 right there. Now it says monoxide. So again, mono means 1, so we write O, and it's just one of them, but again, we don't write the 1 right there, so it's just N, capital O. Selenium. So if we go back up here to where the periodic table is, and we see selenium is right here, number 34. And selenium is Se. There's only one, okay? And oxygen is O. Di means 2, so we have to write CO2. Now here we have phosphorus, P, but it says diphosphorus, and di means 2. So we write P2. We have trisulfide. Sulfide or sulfur is S, and tri means 3, so it would be P2S3. Okay, so that's how we do those ones right there. PF5, so that'd be 1 phosphorus. We don't write monophosphorus. We don't write mono ever on the first one, so we just write phosphorus. And we go, fluoride is 5 fluoride, so we just write penta fluoride. Okay, same thing for here, sulfur. We don't write mono, and we write dioxygen or oxide. We always have to change that ending to "ide" for these things. Bromine, hexafluoride. Carbon dioxide. This one we have to write 2 nitrogens, so it's di-nitrogen, 1 oxygen. We don't write monooxide because that sounds funny. We just write monoxide. Again, 2 nitrogens, so di-nitrogen. 4 oxides. The fancy way of saying 4 is tetraoxide. I know it looks funny when it says triiodide, but it sounds, and we have those 2 I's next to each other, but that's just the way it is. We don't say triiodide, it's triiodide. Carbon tetrachloride. Make sure when you read these things right, like I get a lot of students saying carbon, and then they're saying another carbon, and they think that's an iodine, okay? But just take the second to read that this is what an I looks like, and that's an L. Sulfur pentafluoride. Diphosphorus. Trioxide. Boron triiodide. Okay. Oop, one more of that. This one right here, K is potassium. None of these things get that mono-di stuff because I shouldn't say that. This one doesn't get the mono-di-tri stuff because this is an ionic compound. Potassium right here is a metal. Potassium is right there. Okay. And then the next one is the NO3. So the NO3 is a polyatomic ion. And so that polyatomic ion is way down here. And it's NO3 right here. Okay. So pen's not, there it goes. So NO3 right there. Now, the important thing to understand is this is NO3 minus 1. Okay. And for potassium, my thing's kind of slowing down my computer. Potassium, my periodic table is kind of slowing down. I didn't really see anything, but you're just going to have to trust me when I say this. Potassium is K plus 1 and NO3 minus 1. Okay. Anyway, so this is just potassium, NO3 minus. If you looked on the back of that periodic table, hopefully it's loaded-ish right now. NO3 minus is stands for just nitrate. So we just call it potassium nitrate. Now for this one right here, this is a little bit different. And we kind of have to do Fe2, okay, bracket CO3 bracket 3. And we have to do the reverse swap and drop, and I'm going to explain why. CO3 2 minus. Iron, which is right here, can have a 2 plus ion or a 3 plus ion. So this can have a 2 plus ion or a 3 plus ion. CO3 can only have a 2 minus ion. So when I'm reverse swapping and dropping, this 2 comes up from here and goes to right there. And there's no change. It went from a 2 to a 2. This 3, since this one had no change, this one also has no change. It's going to go from a 3 to also a 3. Since I'm circling that 3 plus right there, that means it is going to be iron. I circled that 3, so that's going to be iron 3. And then CO3, if you look on that back of the periodic table, it stands for carbonate. Okay, so iron 3 carbonate. Now, For this one right here, that iron 3 carbonate, this one gets the Roman numeral because it is multivalent. This one right here does not get the Roman numeral because it's not multivalent. This one right here is covalent, so it has to have that mono di-tri stuff. So this is just carbon, 4 fluorides, so that means it's tetrafluoride. This is also covalent, so it's boron trichloride. This one is ionic, but it's going to be Li plus and Cl minus. It is not multivalent, so it's just lithium chloride. XeF6. This is a weird one, but Xe is way over here. It's very rare that Xe does form a covalent bond, but occasionally it does. So this one just says xenon right there. So we're going to put that in. But since it is technically a nonmetal, it's going to get those nonmetal names. So it's going to be xenon, and that's fluoride, and it's 6 of those. So 6 is hexafluoride. This one's going to be calcium. It does not get a Roman numeral because calcium only has one type of ion. So it's calcium. And if we look on the back of the periodic table, PO4 is just phosphate. This one is, I'll put little arrows beside every single one that is covalent. This one's nitrogen trifluoride, selenium pentabromide. Okay, so there it is. This is your practice test. And once you feel ready about this one right here, you can try doing the real Science 9 chemistry test. And other than that, if you have questions or you don't understand something, message me over Microsoft Teams, and I can try to help you out with that. Do that before you write your actual test, okay, if you have questions. Okay, good luck.